and someone comes, strokes my head. You look back and you see Satish Dhawan. I walked 4 kilometers one way to my school through paddy fields. I felt that chemistry was closer to poetry. He told me the only thing above which nothing can fly is letters. Chemistry is the subject of transformation. Be prepared for a longer time scale.
Namaskar and welcome to another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. We like to think this makes your future simplified. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras, intended to take everything IIT Madras to the global audience: our thinking, our research, our teaching, our startups, our entrepreneurship, our philosophy. Today, for our conversation, I'm extremely delighted, grateful, and honored to be hosting uh, a genius of chemistry, a scientist of global repute, Padma Shri awardee, Professor T. Pradeep. Namaskar, Professor Pradeep. Thank you so much for making the time to come and talk to us.
It's a great pleasure to be here.
Thank you. Chemistry. It is not an understatement when you say the world is made of chemistry. Let's start with your own personal interest, your personal journey. You grew up in a small town, rural Kerala. Tell us a little bit about your your childhood, schooling, and where chemistry came into your life.
Great. First of all, thank you for asking me to be here. It's a great pleasure to be here. What you are doing is amazing. This is quite important for the country and the world at large.
Thank you.
I grew up in a village called Pandavur. It is in Malappuram district, where we got electricity when I was 21 years of age. I studied under a kerosene lamp. I walked 4 kilometers one way to my school through paddy fields, playing with puddles of water. We had cultivation and we had cattle. The life was like that. Those years, well, in my high school, I went to a school founded by Padma Shri Pagaravur Chitran Namboodiripad. He built that school just because of the sheer need of education in that place. And he gave it away to government for just 1 rupee. And so I'm from that kind of a region where people valued education, although they were poor. In my village or my locality, we have two uh, great renowned scholars of Malayalam, both Jnanapita awardees. My father was a poet. I wanted to be a writer. I wrote, of course, wanted to be a writer. But then when I was just completing my BSc, I was asking what to do. I had not heard about IITs and IISc and all that. So I was asking people as to what to do. I didn't have any kind of thinking as to technology could be a way forward. After my PUC, I did not know about it. Only thing I knew about it was medicine. My friends went for medicine. I decided to stay with science, although I got an admission, stayed with chemistry because I felt that chemistry was closer to poetry. I wanted to be a poet, a writer, just like the writers around, well known. What would be that which will get me bread while nourishing my appetite for language. My father was unwilling to send me to literature. So he said, do whatever, but it should get you bread.
Mm.
So I told him that maybe chemistry because it is closer. I can satisfy both these worlds. So I went to chemistry. And well, during MSc and BSc and MSc, I wouldn't say that I had this orientation to do advanced chemistry. After MSc, I realized that I had no knowledge of chemistry. This- Well, I had seen some big, thick books, but I don't feel it. Within me, I never felt that chemistry was something known to me. I said I would do a PhD. So where do I do a PhD? I did not know, as I told you, about Indian Institute of Science. I went to my university, and a professor there, well, I'm thankful to him. He told me, not here. You should go to
What's the name of the professor?
Kannan, Professor Kannan. So he told me, uh, not here. You should go to Indian Institute of Science.
Hmm.
I went to Indian Institute of Science. There I saw towering figures, towering. And just being with them was transformed me, mesmerizing. Uh, and that I decided that if that is chemistry, I wanted that chemistry, and I wanted to be a professor, and that was this transformation.
Hmm. Was there a defining moment in your high school that said, I will do a BSc in chemistry? Did you have broadly good chemistry teachers in school?
Yes, there were good chemistry teachers. I wouldn't say that the motivation rather to continue in chemistry happened while I was doing BSc.
Okay.
There was a teacher, Professor KP Anthony. His son also studied here. So we recognized him with a Distinguished Alumnus Award. So he, so Tommy, we call him Tommy. He studied here. So Professor KP Anthony told me that chemistry is everything. Uh, and you can be, going to whichever shop. I don't want to mention those shops. So you can be in any shop, but you can actually enjoy chemistry.
Nice. So, looking back, walking 4 kilometers is a challenge for a young child, I'm sure. But what was in your mind? Once we start to walk, we get used to it, right? But what was the biggest challenge in your mind um, for you to decide to go up to a BSc, then MSc, and then PhD? Were there challenges that were around you that you needed to overcome in some subtle way?
My parents were both school teachers. They valued education as this supreme thing that one should have is the capacity to learn. And my father used to say that there is only one thing above which nothing can fly. You know what that is? You would ask me. And he told me the only thing above which nothing can fly is letters. Go and conquer that. And for that, whatever that is needed, we were ready to do. So, in that sense, although there was this distance, there was this walk, and there was this village life, income was limited,
Mm.
communication was difficult, contacts were not there, no advice of kind that you are giving, not there. But I wouldn't say that any of these was a barrier in if you wanted to seek something, that would have been possible. But I would say if I had known about great institutions, great teachers, I would have had another path.
Mm.
Maybe in chemistry itself, but a better path. So that way, what you're doing is excellent. So to me, if at all there was a barrier, That was that information was not available at the right time.
Hmm. Let's now talk about the towering figures you met at IISc.
Yes.
I'm sure they had a lasting impact on you.
Yeah.
What was life like at IISc doing research? And let's talk about your own gurus.
Professor Rao is he just turned 91. His influence is all around you. He's an institution builder. He's a great science communicator. He's a great scientist, great teacher, great philosopher. I wouldn't say that there was a discipline that he wouldn't like. He was a total teacher. Mm. Like I know that you earlier mentioned about M. Sharma in one of those discussions. So this is a complete teacher. Professor Rao was a walking encyclopedia. Mm. I had once mentioned about that. You walk with him, you hear about things that you did not see in Encyclopedia Britannica. That's the kind of thing that will come from him and his personal anecdotes. So Professor Rao, whenever a person came, a good person came, a researcher came, he would take him to me, introduce him to me. Hey, here is this person. Talk to him. He would expose whatever that is around him to you, and he was carefully mentoring you. Over the years, I have traveled with him to many countries uh, after joining here. But I was not. I saw that CNR was a scientist who was transforming you for the larger need of the country. I wouldn't say that he would do that for everyone. Uh, but in one of his interviews, he said that every student who worked with him gave everything to science. So he could get that, inspire every individual to perform at his best, his or her best. Uh, Now, you asked about other people. So one day, my first year, I was just walking uh, by the side of the administrative main building, and someone comes next to me. It strokes my head. How are you doing? We look back and you see Satish Dhawan. Wow. And I just wanted to know what how a young student is doing. And there is, of course, Rodon Narasimha, you mentioned briefly, uh, Professor M. Vijayan, Professor Kumar, Professor Vishwamitra. I can go on, Professor Balram. So, great many people, highly influential, highly knowledgeable. But one thing, they all wanted you to be successful. So, to give you an example, I was just completing my PhD. I did not have enough money to, well, for this postdoctoral offer was there at Berkeley. Uh, I did not know how to go. Ticket was not there. Money was not there. So um, I was just walking around. I saw Professor Gandhi, a chemical engineer, and this is my problem. Don't worry, I am going to give you this tomorrow. Come. And I took that 25,000 rupees from him. And what he told me was this, that, how do I return this money to you hereafter? For you, this is nothing. I want you to be successful. Of course, I returned the money, but the words that Gandhi spoke, that represents that institution.
Wonderful. Wonderful. I'm sure it was a very rewarding atmosphere to be doing good science. And you carried that fervor to Berkeley, then to Purdue, and then you came back to IIT Madras.
Yes.
Today, you run what anybody would say is a world class research lab out of India here. you compete with the best scientists from across the world and you're able to produce research right here that can compete with the best people in the world. I am sure it was a struggle to get this far. I've seen you. I know how hard you work. Let's come to chemistry as a subject. Why should a young man or woman listening to us today say chemistry is an exciting field? What in your mind really sets chemistry apart?
Chemistry is the subject of transformation.
Subject of transformation.
Transformation. Matter. Matter, it can be organic, inorganic, what have you, biology, whatever. You transform that with molecular understanding, and that is chemistry.
Hmm.
You make or break bonds, that's chemistry. So I would say transformation is chemistry. Transformation, well, will happen under rules.
Hmm.
You understand those rules. How transformation occur, you evaluate that. How can you enhance that? How can you decrease or reduce that? Decelerate it? How can you make transformations to achieve what you want? For example, a functional material or a drug, a pharmaceutical or a polymer, what have you. So this is chemistry. So if you look at it from this perspective, you have many problems of our planet which cannot be addressed without chemistry. How do you address CO2 problem? How do you convert CO2 to methanol or to hydrocarbons? How do you run a hydrogen economy? How do you take out the CO2 from the atmosphere today and reduces global warming? How can you provide clean water to people? How can you have better medicines? How can you have better pesticides? How can you have better agriculture? So if you keep asking these questions from a very broad perspective, how do I change the world? This changing the world, you can do it in many ways, but without materials, you cannot change it at all.
Hmm.
It's great to have machines flying, but how did the machines fly? It's great to provide people with clothing. How would you have 7 billion people wear clothing? How do they eat? Without ammonia, where is this world? So if you start thinking about it from a broader perspective, how do I change the world? I would change the world molecularly. And that would be kept.
Very nice. And why do you say India is a good place today to choose a life in chemistry, career in chemistry?
It just as any in any other area, India is a pot of boiling problems. As we just mentioned about all of those issues about water, climate, etc. All of these, I'm just coming from a village where it's an agricultural village, uh, but one out of every 4 homes there is a cancer patient. How did this happen? Indiscriminate use of pesticides. How did this happen? How did that kind of chemicals get into our soil or water? How did it affect our health? So it's a time bomb ticking. You need to find something new. At the same time, have productivity, right? Agricultural productivity, we can't afford it to be lower, but we need greater environmental protection. So, like this, hundreds of issues are there today. If you wish to address or make India the Bharat that we are talking about, the Atmanirbhar Bharat, or you're looking at it from a larger perspective, how would India be a developed nation? This is impossible without chemistry.
Mm.
So that has many facets to it. You may address it from the point of view of, let us say, Yamuna, clean Yamuna. You may address it from the point of view of of clean Delhi. You may address this from the point of view of providing water. You may address it by providing better clothing. Uh, Now, look at the microplastics pollution. Look at the fibers. All of these in India, the impact of this is going to be tremendous because the population density is such. So all these plastics that in America or in Western world may not have greater impact, but the impact is going to be here. So to me, India is the right place to address these challenges. Now, will these challenges give money? By addressing them, you will get satisfaction. Those are additional questions. We'll come to that. Yes, those. But this is the right place to address those because the problems live in front of you.
Sometimes chemistry is viewed as a difficult subject.
Yeah.
At the school level, 10th, 11th grade, 12th grade. What's your response to that? And what can we do collectively to alleviate that perception?
You know, chemistry has undergone tremendous changes. Let's remember that it is atoms, the idea of atoms was introduced only in 1800. It's just about 200 years old. The first molecule synthesized, urea was synthesized in the laboratory, 1828. So it is a very young subject, and from that perspective, so much to be done. But in that process of building chemistry or creating this structured chemistry from Lavoisier, from the very first textbook of chemistry, chemistry has been divided into several subtopics. And that kind of structured chemistry and the structured teaching has probably taken out the real excitements of chemistry from away from the subject. Talk inorganic chemistry. Inorganic chemistry is taught outside the world, the environment outside. Physical chemistry is far removed from the environment outside. So that way, the excitement is not there. Chemistry is something dead on the, blackboard. So we need great teachers. Chemistry has to be felt. Chemistry, you have to feel it in front of you. This water is being talked about, H2O is talked about, but H2O is not talked about from the perspective of this large Ganges. The young kid does not feel it. So imagine, you're a fluid dynamics person. Looking at this from fluid dynamics, you look at it, aerospace engineering without fluid dynamics is what?
Nothing.
Yeah. So the the equations have to stay with these machines. And that is when the student gets excited about it.
That's a beautiful perspective. Start with a problem that a particular concept in chemistry could solve or address. That's a nice way to motivate a young child to remain connected to the subject.
So you see, we're talking about catalysis.
Yeah.
But the greatest catalysis, if you keep your catalysis away from that, then the flavor of catalysis, the charm of it, is lost. So there are great many catalysis courses, but they don't take these kids to great catalytic converters where things happen. These towers that in which I was just standing in front of one of those towers of the ammonia synthesis, the Haber-Bosch process. If you don't feel it, that process, you don't feel it, then what is catalysis?
Yeah.
Why should you do catalysis? Why should I study these equations? So this internally boils inside you, and over a period of time, this keeps on boiling and nobody is answering this. The student gets dejected. So they need to see practitioners of any subject.
We'll come to that. A lot of what you have done in your own research has been motivated by a societal impact. We'll come to that. I think let's talk about your work. You are broadly renowned for your work in nanomaterials. You run a center of excellence in molecular materials. What got you to the materials end of chemistry? What is the excitement there? And tell us a little bit about some ideas you are now working on.
Well, great. I started doing spectroscopy for my PhD. Yeah. And for this, built spectrometers. And I went to Berkeley to do supersonic nozzle beam spectroscopy, uh, ultra cold gas molecules, dimers, argon dimer of argon, and studying the vibrations of these like that. I came back. I saw that I can't do anything here. And there was no infrastructure. I just wanted to mention that I went through a period of infrastructure limited science.
Hmm.
There was nothing, almost nothing. So I walked around every corridor I used to walk, and the question inside me, or what I was looking for was, is there a junk instrument that I can somehow convert to a machine of value? So I picked some things and I started doing some science. That's how I started. But in that process, I was asking this question: what kind of science? The science that I do, how can it be useful? And that took me to materials. And I stayed with materials. I wanted to be Professor Rao is doing great science. My postdoctoral advisors were doing great science. People around me. I wanted to have a distinctly different path. So I chose to do different science. Subsequently, in all these years, I went on with a different path. This is not practiced by people who have trained. But a fundamental question was that why at all I do this? I must have a connection, even some 10%, 20%, some connection. And I chose those problems where this connection is of relevance to the country.
Hmm.
So today I work on many areas, but all of them are greatly relevant for our country. And they are all cutting edge. Uh, so two conditions I put on my research. Is it the best that we can do? Is there an element of my country in it? A bit in my a bit with the country meaning a bit for my institute, bit for my people, bit for everything, bit for my country. Hmm. That to me, as I said, chemistry, right? Transformation. So I can't think outside molecules, outside chemical bonds. Our discussion is all molecular for me. What I see you as a molecule, as I see everything that is as molecular, and that's because of the training. Because as a musician, for a musician, everything is that, right? So it makes you that, right? Right. So as a result, I look at larger problems, but from the eye of a chemist. Mm.
Very nice. I want to hear the story of your fight against arsenic. It was at least one of the early successes that I heard of in the public media coming out of your lab. There's been a lot of other work also. Tell us how this idea of fight against arsenic started. Who are the actors in this play, and how did you? Where is it now?
Yeah. So it all happened around 2000. 2000, there was this news report about pesticides in water. And and I was asking, what is that I can do to address this problem? So I then asked this question, what is a pesticide really? Pesticide of relevance to India, they are all halocarbons. Like a chlorine and a carbon bond, or a halogen and a carbon bond. So how can I break a halogen carbon bond? In that process, make this pesticide uh, degraded. So that took me to halocarbon degradation. And that was my first patent. Okay. And that was taken up by Eureka Force. So fortunately, it was that uh, that one work, the very first one, was taken up by industry. We got about 2.5 crores of royalty for the institute in that process. Now, there is another side to this story because it is important for students to know. Therefore, I'm saying this. It did not become a success just because somebody invented something and a society was ready to take it. I had to go through a mechanism. This was, in this particular case, was a friend. Mm. A friend, I was telling him that this will have great impact for water. So can you please connect me to an industry? He said, well, I will connect you. You're a friend of mine who is working in that industry. He took me to that friend and he took me to the management. The management had no idea whether this will work or whatever, but they felt that this man is very important for the company. And whatever he says will have some value for the company. That person felt that this idea is being told by his friend, and his friend will never say something wrong to him. And ultimately, it was like this, that the management felt of this company felt that whatever he says may work, may not work, but this guy is great. Hmm. We should help him. And therefore, they took this technology and it was successful. Now, it has reached about 10 million people. Great. They sold filters of that many filters. Each filter, if you say that it gave clean water to 4 people, so that way we have 10 million people. Okay. But this was one such, I felt that water problem can be addressed in just 2 years. That's how we went into that subject. Because there are so many contaminants and each one can be addressed by different chemistry and the whole thing is gone. Having got into this, I went to different parts of the country. Hmm. Then I saw problems which are massive. The arsenic problem was one such. Right in front of you, you make people, you have debilitating conditions. People who can't focus on their studies. What is democracy that you are having if all your people cannot be given equal opportunities? You can have a young kid from an arsenic affected region to win Olympics. Then what kind of country are you? What kind of educator are you? So it was deeply upsetting to me. And this is a problem that can actually be addressed because arsenic is something that can be removed by good materials. But these materials have to be effective for both the forms of arsenic. Arsenic 3 plus and arsenic 5 plus both exist in water. Equally effective. This material should remove arsenic in these two forms at equal capacity, kind of similar time scales, similar kind of cost. Mm. So this is addressable. I worked on it. I would say the reason that I worked on arsenic was principally because I saw the problem in the field. Secondly, I saw that this is really tackleable in the time scale that we have. Mm. And I was fortunate that there was a district collector who at that point in time said that please test this idea. And he was also there to write an agreement uh, after the successful trials. So we got our first large scale implementation. Mm. To put it together, it was, and I should say that this whole thing was possible because of a great institution. I remember after signing this, agreement of 20 crores. I came back. Bhaskar was the director, Professor Bhaskar Ramurthy. And he looked at me. Now, before that, I asked him, do I have permission to go and sign this agreement on behalf of the institute? Yeah, go ahead and do. And I went there and did that and came back. And Bhaskar told me, you've taken up a great responsibility. All you have are a few students. How do you provide clean water to all these people? I said, Bhaskar, all that we have are our young kids, but you send them to US and they transform San Francisco.
Yeah.
So that's my answer to all these. That is, we produce good people, great ideas, and they will change the world.
Mm. Both your examples, your halocarbon removal example and the arsenic removal, you alluded to the power of a network that helped you. A friend in the first case, a district collector who was a bit proactive in the second case. I think we don't quite realize how important these networks are. Your own personal network, professional network that keeps us going and helps us in times and ways that we can't imagine. You have been a vocal voice for science for social impact. Chemistry is your discipline. You've done chemistry for social impact. What can we do to make that voice be more amplified? I mean, uh, you talked of how even at a young age, social impact problems can motivate young children to come study chemistry a little better. Are there other social impact problems that you think chemistry can solve? What are some that you're now working on?
We have adopted a village. This village is near Coimbatore. We see agrochemicals and pesticides, what is happening to the village because of this. It's a team effort, a larger team of people, physicians, scientists, uh, engineers. Now, very recently, DST has agreed or approved a large project to address this problem. So there are many, many such villages where problems exist, whether it is this agricultural rural village, or it may be something affected by dyes and pesticides and what have you, or it may be chromium or any other contaminant that is there. So there is this environmental issue. This is one side, one large set of problems that chemistry can address. Now, in a way, air problems of air that you are having, we are also chemistry related questions, aerosols and um, now, you could look at issues such as, let us say, this ADR, QM, that is there is also a chemistry problem. But all these are largely around environment. This can be addressed collectively by us, but can we address an environmental another problem? For example, there are resources available, agricultural resources available, materials available. Can you convert them to something? Is there a utilization? Look at our my own region, coir. How can you address coir better? Can we convert this to composites, better composites? Uh, is it not possible that bamboo is a great resource that is there? So bioresources, addressing them is a challenge that chemistry can address. Now, it need not be just this agro. This can be uh, seafood related products. So there are several industries out there, but all of those industries are also having challenges. They are they continuously impact environment. Now, ours is a country wherein cost is a big issue, barrier for every. Sure. So we have uh, construction materials, paints. All of these, are there better ways of making them? We don't. I keep visiting industries. They're all using technologies which are 60, 70, 100 years old. Is there a way to address or offer chemistry support, science support to them? we are somehow not interfacing adequately to address these problems. To give you an example, there is there's a one place where over 200 million tons of acidic iron oxide is stored. I mean, these are legacy sludges. What do we do with these? How do we change the technology for tomorrow so that this is not produced? So, in our country, technologies are not being upgraded because industry is not linking with science in a proactive fashion. When there is an environmental catastrophe, we address them, and that too to a limited extent. The institutions, if we start addressing them, I'm sure there are problems of this kind, whether it is industrial problems, whether it is agro residue problems, or environmental problems.
That brings us to the sort of the next logical segment that I wanted to talk to you about: careers in chemistry. Before we get there, what are the different disciplines and sub-disciplines in chemistry, and what are some careers there? Let's start with different disciplines. I only know organic, inorganic from high school, but I'm sure there is much more nuanced way to think of this.
Traditionally, chemistry teaching is in three baskets: organic, inorganic, physical. And analytical is also an important component. And Indian institutions provide degrees in chemistry or in these four branches separately, specializing in these branches. But you can also have pharmaceutical chemistry. You can have cosmetic chemistry. You can have food chemistry. And then computational chemistry.
Biochemistry.
Yeah. So biochem. So these are all different kinds of chemistry that you can get, and people do offer these degrees. So there are other disciplines like pharmacy. Uh, this is actually pharmacology, pharmaceuticals. They're all having great connections to chemistry, polymer chemistry, metallurgy, all of them. Uh, but chemistry in general will come in these 4 or 5 different flavors. If you wish to be a chemist, pure chemist, wanting to explore higher horizons of chemistry, you may stay with these. But you are looking for newer adventures in chemistry, opportunities in chemistry. I was just looking at where would the next opportunities be.
Mm.
And you can't think about a world without artificial intelligence today, data science today. Chemistry and data science is a great opportunity. New discoveries in drugs and pharmaceuticals, new opportunities in catalysis. Chemistry, without chemistry, there is no catalysis is chemistry. But the great discovering new catalysts require chemistry input. So is it possible, if you want to start looking at new opportunities in chemistry, data science is certainly one. And secondly, I would think of cosmetics is another great opportunity. Food science and technology is another opportunity. But these are all opportunities when you want a career job.
Hmm.
So I'm looking at chemistry after this next word. How do I earn a living? These would be my suggestions, because pure chemistry is gradually declining. I don't want to hide this fact. Be honest about it, that pure science, pure physics, pure biology, the way it is largely providing opportunities for those who want to climb up that how, why question ladder. Those who want to earn a bread today, they look at options of this kind.
Okay, that's a good way to parse. Be more of a food chemist or a cosmetic chemist, and there is a much greater chance of a livelihood there.
Absolutely, and there are opportunities are available tomorrow.
Hmm.
And pure chemist path is a tedious path, and it may go to several years. A typical PhD in chemistry is about 5 years. And just after a PhD, nobody is going to give you a good job. You want another 3 years of postdoctoral training. So it is 8 years. And even after 8 years, it may not be possible today. So opportunities is another segment that I would like to talk about. But then, if you wish to pursue that great feeling of chemistry, why things are working, how things are working, how do I impart a new property to material? If you want to discover those, the path is tedious. Uh, but then, to be a great mridangam player, you need to spend at least 12 years.
Yeah. Same goes here, I think. I've been told by some people that for a large country like ours, being the world's pharmaceutical manufacturer of generic drugs, we don't have enough catalysis chemists. We don't have enough, synthetic chemists. We have quote unquote generic chemists, but I think the message I'm getting from you is specialize in some small aspect where chemistry can be applied directly. That's a nice.
If you wish to be pursuing pure science at its highest peaks, you be prepared for a longer time scale. If you are looking for opportunities to engage with something to get your bread, you be open, explore other areas as well. While pursuing your degree, get this additional thing. Or look for another 1 year, 2 year course directed towards some one of these.
Hmm.
Uh, and then there are opportunities.
Very nice. You've been a mentor to hundreds of students. When you've had mentors in your own life, what qualities would you say? Now we are talking research careers. What qualities do you think a young student should come with to say you will make a good research student and you can make a good research career?
Researcher must have this capacity to question,
Hmm.
the inquisitiveness, capacity to do consistently hard work, the capacity to communicate effectively. So in each of these, you can nurture those as well. So I may say one of these qualities may be a little less or whatever, but inquisitiveness is central. We have a diverse country. Students come from all over. Their level of preparation is different. So I'm now looking at this large pool of chemists, potential chemistry aspirants in front of me. I would say that if you have that in you, then please look at research as a possible option. Others can be nurtured.
Very nice. You're one of the early path breakers where you brought the idea of entrepreneurship into chemistry. Let's talk about your own startups. Uh, Vayugel was the latest one that I know of. I'm sure there have been others later. Um, Tell us a little bit about the spark for entrepreneurship and where is it taking you? And what does a young student need to look for within himself or herself to say, I think I can do it too, like Professor Pradeep did.
Chemistry and entrepreneurship in chemistry is a drive to see a different world through transformations. If I have some way to make better water, if I have some way to make water from air, if I have some way to detect contaminants in water, if I can have use all these data about water and provide better water, reliable water. These are the areas in which I have worked on and I have built organizations. I saw this happened, one, because of a great need,
Mm.
great need. I also did this because I had the right people. And I also saw that this gave me satisfaction. If I don't have a great student or someone who is ready to take this as his or her life, I haven't started. So this is my requirement. So if the entrepreneurs who are listening to this want to address a chemistry challenge or a societal challenge through chemistry, you need to ask this question: that are you ready to run with that idea? And I had all my people who took this kind of challenges. They struggled. They struggled, lived with minimum resources. Although they could have gotten better salaries elsewhere, they stayed with it, pursued this till the very end. And even today, they are pursuing this. Now, water is not a subject, not the only subject that you can address through chemistry. Water is a subject wherein probably rewards are lesser, financial rewards are lesser.
Mm.
Because water is one thing that everyone wants it, but at a reduced cost.
Yeah.
And it is like air. Everyone wants it, but nobody is willing to spend on it. So therefore, there is not enough money to pay. But there's great satisfaction. You might want to work on gold. You want
The origins of chemistry.
right. You want to yeah. So uh, I think rewards are very different for different people. People look at a mix of rewards. So to me, when I go to a village and then they say that this has, this has changed my life, I think it is much more than all the financial rewards that technology can give us. But money is also needed. Yes.
So let's step back. Let's look at uh, your professional life as a faculty member at IIT Madras. You've achieved the pinnacles of good research. Uh, you've also translated them into usable products. You've spun off companies out of your lab. Among the many successes, what gives you the most satisfaction?
Greatest satisfaction as a researcher, for me as a scientist, as a professor here, is discovering new things.
Mm.
This is like, whether what is dear to you, your wife or your mother. It's like um, research is really dear. New findings are really exciting. I've made excellent discoveries here, cutting edge. But I have also changed people. I have seen students how they came, I've seen how they went.
Mm.
I have been instrumental in this great transformation. I've seen that. I have seen that how my institution has also transformed. So all of these have been greatly satisfying for me. To give you an example, when long ago I told you that infrastructure limited science, it is difficult to do anything. So I used to go every now and then to Bangalore. Every summer, I used to go to the US. I used to, Professor Rao, I would ask him, okay, do you have some time? Hey, come in, come in. So I would hold his hand and he would ask me, why have you come? I would say, I came to enjoy the smell of science. I would go to US walk through these corridors of Purdue or someplace, my former advisor would ask me, "Why did you come?" I came to feel science. Today, people come to my laboratory to feel science. So this is a great thing for a scientist. It's a great satisfaction. I have seen young kids transforming completely through this thing that you do called, your life, your journey. Be part of that journey. This has transformed them irreversibly, and this what you have produced through them, through your intellect, through your capacity, has added to things that are there in the textbooks today. So from all these perspectives, it has been a great year.
Wonderful. What's the one advice you'd like to leave a young student with, uh, someone who wants to become a chemist and make an impact like you?
You want to change the world through molecules? This is possibly one way. Transformation can be effected in many, many ways. You can be a great poet. You can be a great speaker. You can be a great politician. All of these are ways to transform. A chemist makes lasting transformations in society through molecules, through chemical bonds, through change, molecular change. So I'm asking you, my answer to you is that, do you feel that a big change can be made by molecular transformations? You choose chemistry. You can do that with electronics. You can do that with power electronics. You can do that with energy. You can do that with anything. Uh, but at a young age, it may not be possible for you to see whether molecular transformations would give you the satisfaction that you desire. You require the support of a mentor. So you must consult people around you. Is this the right path that you're choosing? Now, India is at the right time. Institutions are at the right time. I can tell you that IIT Madras, especially, is in the right place, right time, right environment.
Sure.
But institutions across the country are transforming. The world is transforming. So, in that large world, some point in time, if you have to do chemistry, people would say, go to Germany. Some years later, people said, go to do chemistry, go to America. Today, to do great chemistry, you can go to many places, including India.
Wonderful. We are no far behind. We're at the cutting edge with the rest of the world. That's a great message to leave a young man or a woman with. Professor Pradeep, this has been a fascinating conversation. I think the prospects are endless for the next 20, 30 years for a good chemist motivated by societal impact in India. You've led by example in that respect. Thank you very much
Thank you very much.
for
Thank
coming
you.
here.
It is indeed, it has been a great pleasure talking to you and sharing this information with all of you. Thank you very much.
Thank you, Professor Pradeep. This is another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. Brought to you by IITM Global, an initiative of IIT Madras to take our thinking to the world audience. Thank you for listening. Be well, do good, and keep in touch. Namaskar.